All right, so on this first one, they just give us some, functions here and values. They don't give us much of anything else. But what we're supposed to do is remember that if we have h of x equals f of x times g of x, then we have to remember h prime of x was going to be the derivative of the first, so f prime of x, times the second, g of x, then plus the first, f of x, times the derivative of the second, g prime of x. So now we just have to plug all these things into here, and we'll get our h prime of 2. So f of 2 is 6. Well, that's going to be over here. So that's going to be plus 6 times. Now f prime of 2, that's over here. So that's a negative 1.5. And then we have g of x, or g of 2 rather, is 4. So that's going to be times 4. And g prime of 2 is 3. Well, that's over here, so that's times 3. So now if we plug all that into our calculator, 4 times that, that's going to be minus 6 and 18. That's going to give us 12. And so that would be the solution they're looking at here for. And again, we found that that's the product, and so we knew we had to use our product rule, and we have this, and then we just plug in the values they give us for each of those different pieces, and we get our value of 12. All right, what about this one? So we have demand. So let d of x be the demand in units for a new product when the price is x dollars. Okay, so what we plug in here is going to be dollars, and we're going to get out units. So we're supposed to write sentences interpreting the following. D of 6.25 equals 1,000. D prime of 6.25 equals negative 50. All right, well, what we can say is here, when the price is 6.25, the demand is 1,000 units. Okay, so we're just directly putting in the dollars and the units, and we can write it out that way. Now this one's the derivative, so remember when you have a derivative, that's the rate of change. So we can say again, when the price is 6.25, now the demand is what? Well, it's decreasing, and it's decreasing by 50 units, and per every dollar. So it's per dollar of price, because we're not going to differentiate how it's going to be. So it's per dollar of the price, whatever that is, x. Okay. So that is how I would interpret the d prime 6.25 equals negative 50. Now, we're supposed to write a formula for the revenue, R of X. Okay, so we're going to have some R of X generated from the sale of the product when the price is X dollars. Now we're going to assume demand is equal to the number sold. All right. Well, how do we figure out revenue? Well, we're going to have to take how many we buy. So the number, or not buy, but sold. Number sold, and then we're going to have to take that times our price. Okay, or we can take the price times the number sold. It really doesn't matter. Okay, so what would that give us? Well, if we write our price first, that is x. So we're going to take x times, and we're going to take it times the number sold. Well, it says demand is equal to the number sold, so that's just going to be dx, okay, because we're just keeping everything in terms of x. So that would be our revenue. The basically your price you sold it for times the number you sold is going to give you your revenue. So that would be B. So we did A right there, B there. Now it says C, calculate and interpret R prime of X when X is equal to 6.25. Okay, well, we know that 6.25 is the price. So we're going to say what R prime of X is equal to is, now we need to take kind of the derivatives of these, right? Okay. So we take, and let's say if we call this one, f of x, and this one, I guess we can keep it d of x. So f of x is equal to x, so f prime of x is equal to 1, the derivative. Now, if this is dx, which makes sense because it's a function, so we don't have to rewrite it as a different function. So d prime of x is going to be its derivative. So we couldn't really just say that. And what we would do normally is we would say d dx with x here. Okay, so we'd have that here, the derivative with respect to x of x. Well, and I'm just rewriting it, saying, okay, well, call it f of x is equal to x, then f prime of x is equal to 1. And what we could do here also is, well, that's this. Well, we could say instead, we could say d dx of dx. So we want the derivative of dx. Well, that's going to be just d prime of x. Okay, so now with our derivatives over here, our original functions here, we can say, okay, well, this is going to be, first is going to be the derivative, so it's going to be 1 times, then dx plus, now the original was x times the derivative, so it's going to be times d prime of x. Okay, now, do we know anything? Well, we know d of 6.25, since we're likely using the same number, is 1,000. And so that's going to be 1 times 1,000 plus x, which is 6.25, times d prime of x. Well, d prime of x is a negative 50. And so if we take and plug that into our calculator, we have 1,000 and then plus 6.25 times a negative 50. So we get 687. Okay, $687.5 is the revenue per dollar of sale price. Okay, so that's going to be that. So our revenue is going to be, increasing by $687.5 per dollar of sale price. And I'm not going to write all that out, but that's what it's going to be. Okay, so that would be our value for this one. All right, so what about this one? Free throws. All right, so it says a point guard for the NBA team averages 15 free throw opportunities. Okay, so we have free throw opportunities per game. He currently hits 72% of his free throws. As he improves, the number of free throw opportunities decreases by 1 free throw per game, and his percentage of free throws made increases by 0.5 percentage points per game. When his decreasing free throws and increasing percentage are taken into account, what is the rate of change? So we need a rate of change, so some kind of a derivative. And the number of free throw points that this point guard makes per game. Well, what we need to do is we need to first define some items. So let's say, since F for free throws, so let's let f of x equal the free throws in game X. Okay. Now, what we're going to need is instead of percent, what we're going to need is we're going to use proportion. So let's say P of X is equal to the proportion of free throws made in game X. And what we need to remember is to get that, we're going to have to take percent divided by 100. Okay, and so they're giving us some percents here, so we're good there, and we just have to divide that by 100 to find what P is. Now, what's the other thing we're gonna do? Well, now let's call, I don't know, let's call it, I don't know, since I used P for that, let's call it G of X, and let's call that free throw points made in game X. So we have free throws made proportion of free throws made in game, so the ones that actually make it in the basket. And if we multiply those together, we're going to get the total number of points that person made. So our g of x then is really just f of x times p of x. Okay. But we want the rate of change for that. So we really want g prime of x. So we're going to take f prime of x times p of x plus f of x times p prime of x. Again, derivative of the first times the second plus the first times the derivative of the second. So that's kind of the way it's probably easiest to remember, that way your f and p's are in the same places, and you just take the derivative of kind of the opposites on the in positions there. Okay. Now we need to find what is the change in free throws in a game. Well, let's see, the number of free throw opportunities decreases by 1 per game. So this is going to be a -1. Now P of X is proportion of free throws made in game X. Well, how many did they currently make? They were making 72%, so it's going to be 72 out of 100 is how many they're going to make. Okay. Now we're going to add to that f of x. Well, what are they currently making? Well, they're currently making 15 free throws. And what is their change in the proportion? Well, they're increasing by 0.5%. So it's going to go up by 0.5 out of 100. Okay. Now, if we simplify that, we plug all those values in, we'll take, and we'll have a -1 times 72 divided by 100 plus 15 times 0.5 divided by 100, and we get a negative 0.645. And what's that going to be? That's the number of free throw points per game. Okay, so they're going to decrease the by 0.645 free throws points per game. Okay, so he's going to actually decrease in points, even though he's getting better, but because he's decreasing the number of opportunities per game, his overall points per game that he, or I guess he makes per game is going to decreasing by 0.645. All right, so let's stop there and we'll come back with more.